Introduction to vectors. First off, let's start with some important vector terminology. A vector is a quantity that has both magnitude and direction. For example, a car travels at 40 kilometers an hour east, or a plane travels at 280 kilometers per hour northwest. A scalar, on the other hand, is a quantity that only contains the magnitude. So like the movie cost $8.50, or the average on a test was 78%. There's no direction. A vector is represented by a line with an arrow on one end. The length of the line represents the magnitude of the vector, and the arrow shows the direction. So we've got vector A to B, 45 kilometers per hour, going north. And we've also got vector C to D, 20 kilometers per hour, north 40 degrees east. Algebraic vectors can be represented in many ways. Some common ones are as single letters, so vector U, vector X, vector V, or they can also have magnitudes where the direction doesn't actually matter and we're just looking at the total displacement, and we use that with the absolute sign. We can also have two letters, which are point-to-point vectors, which show you from point A to point B, from X to Y, or from B to A, and these also can be written as their magnitudes where the direction doesn't matter. Important thing to remember, the order of the letters determines the direction of the vectors. Two vectors are parallel if they have the same or opposite direction. Two vectors are opposite if they have the same magnitude and opposite direction. And when two vectors are opposite, one is the negative of the other. So two vectors are equal if and only if their magnitudes are in the same direction, are the same, and they're going in the same direction. So let's take a look at this diagram. We want to come up with two vectors that are parallel. So for no reason, let's just look at vector A to B. And let's consider another vector that's the same, that's parallel to that. Well, vector C, D is parallel to that. Let's look at two pairs of vectors that have equal magnitude. Let's look at AB again. And we could also say that CD has the same magnitude. So we can write this that the magnitude of AB is equal to the magnitude of CD. We can also say back up here that AB is parallel to CD. Okay, let's look at two things that are opposite. Well, vector AB is opposite to vector BA. That means that AB is equal to the negative of BA, the opposite of BA. And two pairs of vectors that are equal. Let's look at AC. Well, AC is equal to BD. The measure of an angle between two vectors is determined when the vectors are placed tail to tail. And that's an important thing to remember. The angle will always be 180 degrees or less. So we have one vector and another vector, and the angle between them is what we're going to be given. Okay, so we indicate that these are the heads of the vectors with the arrows. And then this is the tail, no arrow. Vectors can be multiplied by scalars. Scalars can affect the size of the vector, only except in the case of making a vector the opposite direction by multiplying by a negative. So let's look at an example. Let's say we have vector V, and let's say we wanted 1/2 V. Well, that'll just be the vector that is 1/2 of V. Or maybe we want the vector that is 2V, so I would take V and multiply it by 2. Or maybe we want the vector negative 2V. Well, that's the same magnitude as 2V, but now it's going in the opposite direction. A unit vector has the magnitude of 1, and this is denoted by u hat. The unit vector has the following properties. So u hat is equal to 1 over the magnitude of u times the vector u, and also the vector u is equal to the magnitude of u times u hat. And we also just need to keep in mind this idea of a zero vector, denoted with a 0 and a vector symbol, which has a magnitude of 0 with no defined direction. All right, so let's try a problem. Let's say a car travels 25 kilometers north and then 45 kilometers north, 75 degrees west. So just really quickly, as a quick reminder, whenever you want to do a directional vector, you're going to want to consider the compass, and then we're going to go, so we're going north, 75 degrees west. So we're going north, but then we're going to go 75 degrees to the west. So this is 75 right here. What is the vector that represents the final position of the car from the starting position? So the vector that we're looking at, here's where we started, here's where we ended, and we want to find this vector right here. Okay, so the first thing that we need to recognize is that this is just a triangle, and let's label these guys. So this is A, B, and C. So we can say that the magnitude of AC, we're just going to use cosine law, is equal to the magnitude of AB squared plus BC squared minus 2 times the magnitude of AB times the magnitude of BC cos theta. AB is 25 kilometers, then 45 kilometers northwest, and then I have to minus 2 times 25 times 45 times cos of theta. Now in this case, I need this theta, so I have to figure that out. So I know that this right here is 15 degrees, because that's how I would get to 90. And I know that this right here is 90, so this angle is 105, okay? So this is why it was important to remember that the angle given is the tail-to-tail angle, but when we actually set vectors up to work within a problem, it's often not that angle that we're going to use to solve the problem. Now I can just easily put this in the calculator and find out that 56.9 kilometers is the distance of the resultant vector. Remember that this is a measure in degrees, so make sure you have your calculator in degrees. The next thing we want to figure out is the resultant angle. So I actually want to know this angle here, because that's the angle of the direction. So sine of that angle, I'm going to use sine law, is related to 45 and is an equivalent ratio to sine of 105 over that distance that I just found. Press multiply and divide, and I will find out that angle A is 50 degrees. So therefore, AC is 56.9 kilometers north, 50 degrees west. And I got these coordinates just because I can look and see that this is 50 degrees away from north in the western direction. For homework, you're going to do page 128, numbers 6 through 10 and 12. There's bonus 121, 3 to 6.